Hello and welcome to section 15.9, triple integrals and spherical coordinates. So what we're going to talk about today is instead of, being defined, our regions being defined by a cylinder, now we're going to talk about our 3D region is going to be defined by either spheres or cones. And so most of this section, when we're trying to find the volume, a lot of the shapes that we're going to have is going to be a region where you have a cone inside of a circle. And so what it looks like is they look like ice cream cones. And so, oops, it's a little thick. So a lot of times our regions are going to look like this, where we have a cone and then the outside function is going to give us a circle. And so our region that we're going to define would be right here. And that's why we call it ice cream cones, right? And so this is when we're going to use spherical coordinates, when we have cones or when we have spheres, that is making up our region. All right, so the spherical coordinates of a point P in space are rho, theta, and phi. All right, where rho is just going to be the distance from O to P. It's the distance from the origin to P. Theta is the same angle in cylindrical coordinates, and theta is the angle between the positive z-axis and the line segment OP. And so note that rho is always going to be greater than or equal to 0, and 0 is less than or equal to theta, is less than or equal to pi. So theta has to be between 0 and pi. It's never going to be negative, and it's never going to be greater than pi. And I'll just kind of show you that. Let's see if I have room down there. Yeah, I'll go ahead and show you that. Well, I'll show you that right here. So rho is just so this is still our, this line coming out from the origin, that's going to still be our radius. But rho, which is actually defined, well, it's defined right there, is just the projection of r up to wherever our, two, objects, cone region, where they intersect. All right, and so that's what rho is, just the projection onto the actual surface of our functions. Now phi is going to be the distance from the positive z-axis, and it has to be between 0 and pi. So this is all of our values. You can go from 0 to pi. Anything negative, we're not going to do. And the reason why that is because, not negative, but greater than pi, we're not going to count. And the reason we're not going to count is because, again, we're talking about circles. So this is going to go all the way around. And to take care of, the opposite side, so to take care of, that angle, what's going to happen is you'll have an x that when you wrap that around, when you have theta is going to take care of, wrapping anything around. So that's why we don't have to worry about going past pi, because theta is going to take care of it for our phi. And so that's why it's between 0 and pi. We don't want to go over, because if we overextend, now we're not dealing with the circle, because we're still rotating this across, how far in theta degrees. All right, so that's why z is only between 0 and pi. I'm sorry, phi is between 0 and pi. All right, so the sphere with the center, the origin, and radius c has the simple equation rho is equal to c. This is the reason for the name spherical coordinates. All right, and so here you see theta. Here you have phi in both, and then you just have the circle. So here's a few equations that you're going to want to know. Again, you don't have to memorize these because everything's open notes this year. The relationship between rectangular and spherical coordinates. So z is equal to rho cosine theta. R is equal to z is equal to rho cosine phi, and r is equal to rho sine phi. Again, we just get that using trig and right angles or right triangles. And then same thing for x, y, and z if we're looking at finding these. So x is equal to rho sine phi cosine theta, y is equal to rho sine phi sine theta, and z is equal to rho cosine phi. Another rho squared is going to be equal to x squared plus y squared plus z squared. And again, that will also give you the distance if you take the square root to find rho. So rho is equal to the square root of x squared plus y squared plus z squared. So let's go ahead and, show you how we can go from the plot and how we can go from spherical to rectangular, and then also I think the next one, go to rectangular to spherical. Well, I'll say that example for the next page, so let's go ahead and just do the first one. All right, example 1. We're going to go ahead and graph this. So I'm going to have a z-axis, an y-axis, and a z-axis. And an x-axis. Let's go ahead and just label this. A z, that's positive x, and that's positive y. All right. And now, we're going to go ahead and we're going to go a distance of 4 for rho. So I'm going to do it at the very end. And we're told that theta is negative pi over 4. So if theta is negative pi over 4, we're going to go back and right in between the positive x-axis and the negative y-axis. And here I just want to, try to bring it out as far as, just about right there. And so I'm going to label that. And so I'm going to use a smaller. This right here, that turn, let me curve that. It's just pi over, or negative pi over 4. And again, if you just want to convert negative pi over 4, doing its coterminal angle to 3 pi over 4, that's fine. They're going to be in the same position. And then we're doing pi over 3. So now pi over 3, again, we're not going, for this one, we're not ever going to go past pi. So again, if I wanted to get over there, pi over 3, if I point in that direction, I'm just going to go a distance pi over 3 that direction. Alright, we're still going to be a distance from the positive z-axis, so that's why it's going to be positive, and pi over 3 is going to be about right there. So that's going to be a rotation of pi over 3. And then, of course, our line is going to be a distance of 4. So, this line right here, we can go ahead and say 4. And so there's our dot. And there is our solution. All right. And that's it. That's all you have to do to graph spherical coordinates. All right, rectangular coordinates of the point, then find the rectangular coordinates. So let's go ahead and do that. So we'll start off with x. So x is equal to, let me thicken that. X is equal to rho sine phi cosine theta. And so we have, for this one, 4 sine of pi over 3 cosine of negative pi over 4. So we have 4 sine of pi over 3 is going to be 1/2. I'm sorry, sine of pi over 3 is actually square root of 3 over 2. And then cosine of negative pi over 4 is going to give us 0. Square root of 2 over 2. Still a negative 3 pi over 2. Alright, go ahead and multiply all that through. You're going to have square root of 6 on top. The 4's are going to cancel each other out, so square root of 6. Now do y. Rho sine phi sine theta. So 4 sine of pi over 3 cosine of negative pi over 4. So it's going to be 4 square root of 3 over 2 negative square root of 2 over 2. That's going to give us negative square root of 6. And then z, again, it's just rho cosine phi. That's my rho cosine phi. And so we have the rho, which we said was 4 cosine of pi over 3. And so that's 1/2. So 4 times 1/2 is just 2. And so our rectangular coordinates are just square root of 6, negative square root of 6, and 2.